Okay, so we'll start off there with the Leave Us at Ordinary Level 2020 Paper 2 question 3. So, in a survey, 1,000 people are selected at random and asked some questions about online shopping. Find the margin of error for the survey. Give your answer as a percentage, correct to 1 decimal place. So that's important. They want it as a percentage and they want it correct to 1 decimal place. So we'll just highlight that. And they're giving us the 1,000 people and they want the margin of error. So find the margin of error. Okay, so we should know that the margin of error is equal to 1 over the sample size, which is the square root of n. And the sample size, n is equal to sample size and in this case the sample size is equal to 1,000 people. Okay, so we'll just fill that in there and we'll get 1 over the square root of 1,000 . So if you were to type that into the calculator, you would get a total of 0.031627766. Okay, they wanted it as a percentage, so to turn that into a percentage, we times it by 100. So as a percentage, it'd be 3.162277766%. They wanted to correct to 1 decimal place, so go back 1 decimal place, draw your imaginary line and look at the number that follows. So the answer in that case would have been 3.2%. And that there was worth 5 marks in 2020. So, part 2. Of those asked, 762 said they believed it was safe to give their credit card details when shopping online. Use your answer from part 1 above to create a 95% confidence interval for the percentage of people who believe it's safe to give their credit card details when shopping online. Okay, so we worked out the margin of error, which is perfect. So we're going to use that now to create our confidence interval. Okay, so we can see there that's our sample proportion is going to be 762 out of 1,000. And then we're going to add and subtract our margin of error for the confidence interval. So, like I said, the sample proportion is going to be p hat. So p hat is going to be the proportion of the sample, so it's 762 out of the full amount, which was 1,000. And we're going to just write that as a decimal, so 762 divided by 1,000 is obviously 0.762. And if we get that as a percentage, it's going to be equal to 76.2%. Okay? Now, we want to create a confidence interval, so I'm going to have to take the margin of error and add that to, subtract it from this and add it to this, right? So, the confidence interval will be p hat minus 1 over n squared. And you should know at this stage that that is the margin of error. And p hat plus 1 over the square root of n, which again is the margin of error. Okay, so just to be sure, this is the sample proportion. We're going to subtract the margin of error to get our lower limit. And we're going to take the sample proportion and we're going to add the margin of error to get our upper limit. Okay, so that will give us 76.2 subtract the margin of error, which was 3.2, comma 76.2 plus the margin of error, which is 3.2. Okay, so that gives us there. So if we tidy this up, we'll get 73, and if we tidy this up, we'll get 79.4. So 73 and 79.4. So that just tells us the limits. So our confidence interval, if we were going to write it out in another way, we could say that 73 will be less than or equal to mu, which is the average, which will be less than or equal to 79.4%. And that year, that there was worth 5 marks. So that brings us on to part 3. So, part 3. It says an online media company claims that 80% of the people believe it is safe to give their credit card details when shopping online. Conduct a hypothesis test at 5% level of significance to test the company's claim. Give your conclusion in the context of the question and give a reason for your conclusion. Okay? So what they're saying there is that 80% of people believe it's safe, and they want us to test whether or not that's true. Okay? So what we need to do is, first of all, we need to take our confidence interval that we created. And what we created based on the sample that they gave us, we created a confidence interval that's 73% or more, up as far as 79.4%. So if this fell within these limits, then I'd accept that claim. Okay? But you can see there 80 is going to be outside of these limits. So 80 is going to be outside those limits. So if that's the case, then we can't accept that to be true. Okay? But when we're doing a hypothesis test, what we need to do is we need to create a null hypothesis. So we're going to say h of 0. And that's the claim. So we always put the claim in as the null. So the claim is that 80% of people believe it's safe to give their credit card details online. So 80% of people, and we can just take that from the question, believe it's safe it is safe to give their credit card details online. So that's our hypothesis, that's what we're trying to prove, right? But we know ourselves from looking at this that it's not true, but we just have to lay it out in such a way that they want us to. So we need to create an alternative hypothesis, and what that means is that we're just writing an alternate claim, right? So the opposite of this claim. So if this claim states that 80% of people think it's safe to give their credit card details online, then the alternative to that would be that the number of people that think it's safe to give their credit card details online is not equal to %, okay? So all we're doing is we're making a claim. So the claim there that we're making is that 80% of people think it's safe to give their credit card details online, but you need to have an alternative which is the opposite to that. So it's saying if 80% think it's safe to give their credit card details online, the alternative that the number of people that think it's safe to give their credit card details online is not equal to 80%, okay? Now, we need to obviously come up with a conclusion, and because 80 is not within the confidence interval, okay, so the reason there is because 80 80% is not within the confidence interval, we can reject. We cannot accept, we'll say. So we tend not to reject, but we cannot accept the null hypothesis. Okay, so what that means there, it sounds all technical, but all they're saying is because 80 does not fall into this confidence interval, we cannot accept the null hypothesis. So we cannot accept this as being true. Okay, and that there ended up being worth 5 marks that year. Okay, so we'll just put in the marks there. So this brings us on to part B. So an aptitude test was taken by 6,500 candidates. The test scores were normally distributed, so we can see they were distributed in a normal bell curve there. The mean score was 480, that's given to us, that's the mean there. And the standard deviation was 90, so they deviated either side by 90. Undistribution shown below, the shaded region represents all the candidates who are within one standard deviation of the mean. So they're even telling us that that's one standard deviation. Calculate the value of A and the value of B. So that's quite straightforward, right? So what we need to do there, we have the mean, which we know is mu. Okay. So we have the mean there. And we have 90 going to the right, and obviously 90 going to the left. So 480 plus 90 will give us 570. And 480 take away 90, so will give us 390, isn't it? So 480 take away 100 is 380, and add 10, yeah, so 390. Okay, you might want to put in the calculations there just so you can see. So 480 take away 90 is equal to 390, and 480 plus 90 is 570. It's no harm to put that in just so the examiner can see how you're answering the question. Okay, the last part there is to use the empirical rule to estimate the number of candidates in the shaded region. So they told us that within this shaded region there was one standard deviation. So if it's one standard deviation either side, that means that this here represents 68% of the data, because one standard deviation either side, okay, which you can see there, represents 68% of the data. So it says use the empirical rule to estimate the number of candidates in the shaded region. So 68% of the candidates fall in that bracket. So 68% of candidates okay, but that's not, we need to know how many candidates were surveyed. So if we go back to the very start, it told us that there was 6,500 candidates, okay? So 6,500 candidates. So it's 68% of that. So 68% of the decimal is 0.68, and it's of 6,500. So 0.68 multiplied by 6,500 gives us an answer of 4420. So the answer there is 4420. And if we just check there, so you can see there, I just filled in the marks. So for the last part, there would have been 5 marks going for that. And for filling in the last part, or the last question there, so part 2, there was also another 5 marks going for the answer there. So there was 5 marks going for getting that part there at the end as well. Okay.